Hey, what's up? I am back. I'm streaming some Atari 2600 emulator, or should I say simulator development. Everybody calls it an emulator, but I think officially these things are called simulators, as emulators are like uh, drop-ins for chips. Like if you were to emulate a chip, you would be trying to like reproduce the behavior of a chip to drop in on a board. Um, Fun bit of trivia as you start looking into hardware and emulator slash simulator development. So we're going to pick up from where we stopped last time. So I will briefly sort of show everybody where we are with this or I'm just going to call it an emulator because I'll never forget or remember otherwise. So we're just going to cargo run our tic-tac-toe bin. So we have this. Despite how janky it looks, this is real. This is how it's supposed to look. Basically, when I built this a long time ago, I just took some text and downscaled it to fit on the Atari playfield, and it looks pretty bad. So, and you can see it's like really uneven and stuff like that. That could definitely be done better, but I was doing this in a bit of a hurry and decided to run with it. I'm gonna turn this music down in my headphones a little bit. Might be a little loud on stream too. One second while I adjust the volume a little bit. It's much quieter. Okay. So that's that. And last time we were getting past this intro screen, to get to the main game screen, which has a lot more interesting stuff on it. So if I hit F, you'll see that I get this message, Riot read not implemented for address 280. That makes sense. That is an input address, and we're gonna sort of probably tackle that in a naive way at first, because we'll want to get past it. We don't really care about doing that yet. We will eventually need to handle input to be able uh, to like actually progress the game. But for I think at first we can sort of gloss over that. But let me give you a quick tour of what I've done in the meantime. So last time I got into some pretty tedious implementing of instructions. I had all these like individual methods for every um, combination of instruction and address mode. And you can see that I've condensed this into a single instruction enum that takes its own out a bit. Levels may be too high. Yeah, you're right. Good to know. Thank you. Let me check that now. I'm not quite in yellow there, but I might creep up. Checking now. That seems a little better. Okay, cool. Yeah, thanks Nomad Pixel for letting me know. I feel like I've been riding the edge of how loud that can be. Cool. Yeah. Can you hear the music at all, by the way? Yeah, cool. Um how are you doing, by the way? It's a late stream for me. Cool. Yeah, that's sort of my goal. It's pretty like soft music anyway. It's some lo-fi stuff. Checking out emulator. Yeah. Um, I've never catch any of the other. There are some other emulator streamers, specifically Rust ones. And there's a Nintendo guy, and I just never catch him when I'm not leaving. So, uh, but we are a rarefied breed on the rarefied breed that does. Yeah, Ferris did a lot. Um, he also did like a lot of work on the N64 before that. Hold on, water time. Which is really cool. I think Virtual Boy is more reasonable for one person to like actually do. The N64 was pretty complicated. Um, so this is so basically I've split everything into um like address executing. So the address like returns a value. The thing that executes the logic doesn't need to know about like too much about like what kind of values can be returned by addresses. A little of this is kind of ugly right now, but I'm gonna worry about it later. Definitely could be abstracted. Um, but what it does mean is that I only had to write everything like for all these things that have multiple address modes, I only had to write the logic once. And for each address mode, I only had to write the logic once. Whoops. Let's see if I can show that. Oh boy. Uh, there we go. Which just simplifies and deduplicates quite a bit. So I actually wrote a part of what took me a long time was implementing all this. I also wrote pretty comprehensive tests for all of it. Let's see. I want capture tests, which means I have a test suite of about 75 tests, exactly 75 tests, including just coverage for every instruction. So hopefully, as we go forward, I'll be working more on sort of new stuff and not just implementing all these slash debugging all of these. Okay, so the next thing I need to work on was address 280. So we can head over to our, where's a good place to do this? Actually, I can see if it's in this. Yeah, so that is our, I don't know how this is pronounced. Swcha. SWCHA. I don't know exactly what that stands for. I'm sure I could figure it out if I wanted to, but this has the um oh, interesting. Paddles themselves. Huh, interesting. Yeah, it's like the inputs like split up between multiple chips on this thing. So like for instance, we're looking at the joystick controllers. I was looking at the paddles. Um like part of the up, down, left, right of both joystick controllers is in this SWCHA uh register on the right, and all ones in the player's nibble indicates that the joystick is not moving, right? Okay, so um this is similar to some other input we've had. It's a, I guess they call it active low. So we'll have to take that into account as we go. But yeah, so the buttons for the joysticks are read from the TIA, and the directions are read from the right, or the PIA. And then the paddle, you can see there's like some triggers on the paddle, but the like actual paddle positions are read from the paddle triggers can be read from the same thing. So okay, but they share a lot of logic. I haven't messed with paddle stuff a lot, so we'll discover that as we go to it. Get to it. So let's see. So I'm gonna go to the right implementation, and read not implemented for 280 was what we were looking for, and get rid of that to do. We're just gonna say if our index 0x280. Does that actually make sense? I think it does. It's been a while since I saw that stuff. For right now, we're going to return just all ones. So that should get us past where we were. And basically, this says there's no input happening. Input can be mapped pretty easily in the future. We have that sort of set up for the buttons on it. But we just want to sort of see how far we can get here. Let's see, map. Cargo run. And then we need enter. Cool. And so then when we hit F to move through, we get something different, which is unknown instruction 04, which is not entirely what I was expecting. So I may have a bug somewhere in my interpretation code, but the good thing is we have a debugger that we can step through. I think we can send in a symbol file so we can see what the code is doing. Sim. See if I set all that up properly. Oh, I probably don't want to do the debugger in here, do I? No, I don't. I want to do it here. There's a breakpoint I can set. Symbol file I can set. Actually, let's not worry about that. I think we'll get there fast enough. Oh no, we will need to break somewhere, won't we? So let's take a look at our cool. So where is it? It's actually sort of deep within our I think it's in our vertical blank. So I should be able to do my cargo run, my debug, break at vertical blank. Our symbol file is tic-tac-toe.sim. And running tic-tac-toe.binary. Okay, so we're now at vertical blank. But we're just gonna skip drawing computer. So we're gonna look for something after the. I may change my sort of debug output there to also output the program counter when it fails. Oh man, my my disassembly is very broken here, which tells me that I do have something wrong. So that's not super helpful. So I'm sort of back to square one with debugging this. So yeah, right, read not implemented for. Oh wait, no, this is the instructions. This is main. What was that code? Which I think if we get rid of this breakpoint, we might get something like a program counter for where we want to be. Okay, so error. It's near second position. Okay, so in fact, I can probably tell how close it is to second position. So it's here. Might be in this sleep 27. Um, so let's see if that matches up. So let's compare with a one value, break not equal third. So what am I seeing here? So then I should see 208 should. These are showing like raw numbers, just not what I expected. But that's fine. I can do the conversion. But I think what we're seeing is that, yeah, so this is the probably loading one. So it's right after the unknown instruction 04. So it's probably the sleep that's doing it, which is the sleep 27. Which let's see what that is. That is some sorcery that happens. It's in this macro file. It shouldn't be using any illegal opcodes. I don't think. If const illegal, no illegal opcodes. Oh, I see. So then it does. So basically what this does is it divides the number of cycles you want to sleep by 2, and then puts that many no ops. So I may have a legal. I may have to implement an illegal opcode, which is interesting. So that should work. Let's take a look at. Let's see if we can find those. I was hoping to not have to deal with those, but it looks like I might, which is interesting. What's this in here? No. Let's see. Let's see if I have a two codes. There it is. Uh, double no op. This argument has no significant status flags. It's a bummer. So that looks like it's a way to. So like it's a way to get it to sleep for 3 without messing with. Yeah. Okay. So. I'm curious why it's bit vsync. What it? Hmm. Okay, fun. Let's see what legal opcode code version does not affect the flags register. Legal opcode version may affect flags. So, insert code. Precise timing is required. Vertical syncs. Available macros. Sleep for end cycles. Um. Pretty soon, I'm just gonna move on from this and just implement this legal opcode. Um. That's super interesting, though. So, I'm trying to figure out how this actually like it invokes that. Um, our Vim setups look the same too, and that's not on purpose. I just like did a full teardown and started over with my Vim config and like didn't add a bunch of stuff. Um, it, yeah, it's like one of those things. Now that I know it, I like it. um, but I'm not. It's funny. Like some people are like interested in how fast you are, and I'm like, I tell them like to be really fast at Vim like is impressive, but you also have to be like really fast like at typing and at thinking and stuff like that. And as you can see, those are not my forte. So it like doesn't, really buy me anything in speed. It does mean I don't have to move my hands very much. I don't have to learn like chorded stuff. I like it definitely. Do I recommend learning it? It depends on how much of a glutton for punishment you are. Um, so VSync. they're pretty good, to be honest. They drive me crazy because they're not quite right, but like if you started with the Vim bindings, yeah, I don't. There's always Windows subsystem for Linux. I don't know if there are like native Windows for everything's weird on Windows. So yeah. Windows subsystem for Linux is like fantastic. You can kind of install like any of the major distros too. Um, there's some weird stuff. Like you got to make sure that you're editing files that are like mostly dealing with files that are in the Linux side because there's a definite cost to like to trying to mess with files that are in the Windows like side of it. I don't know exactly how all of it works, but um, and Vim Qt and it's pretty okay. Mm. Like a graphical Vim. That's cool. Uh, so the thing that I'm running up against is like bit is not an illegal opcode. Bit is a real opcode, and vsync is an address at um at 0, and I'm like just not understanding how this turns out to be 04, other than the fact that bit with a single argument is 24. Maybe this is something that just the compiler knows how to do. Um, I'm just not going to worry about it. I'm just going to implement it. I think this is the only one that we use. And that is fine. There are a ton, basically, like, and I don't fully understand the hardware reasons for this. Basically, every like address that's not specifically assigned an opcode, like, can potentially do something. And they do in a lot of cases. I don't know if they're designed that way or if it's just an accident of like combining things. But uh, basically, like, um, yeah, basically like some of them are pretty stable, and I think this one, this like double no op is yeah. Alacrity, yeah, I have Alacrity on Windows working fine, but I don't know that it was easy to get there. I don't remember how I set that up. But also welcome Valahor. Um yeah, so I'm just gonna go ahead and implement this. And this should be pretty straightforward. I'm just gonna make a spot for it. We're gonna call it like so I just don't get stuck on it. This is gonna be dot, and it's gonna have an address mode, and so we should have some missing arms. So here we'll just go to the bottom of this thing. Say we don't actually do anything with the self dot dot. So we don't actually do anything with the address mode. And then we don't actually do anything here either. So we can actually just kind of return. I think that that 0-page address mode should actually do the right thing. If I set this all up correctly. Um, So we need something here. Missing match arm. Here we go. Probably have one more. Never constructed. Okay, so then we need, where are we, where are we constructing STY? Here we go. X04. And that's going to be dot with 0 page. Let me take a look at 0 page here. Go to definition. Here. 0 page. That's actually not quite the right number of. So let's take a look at right number of ticks. So we actually need to do clocks plus equals 1. Oh, I don't need to dereference it anymore. Awesome. And then we'll just do a quick test for it and make sure everything's looking good. Doesn't affect anything. None of this matters. Just our clocks. And that should be that. So if we test, it failed. Why did it fail? Am I wrong about how 0 page works? Yeah, I must have done something wrong with how I implemented dot. Oh, I do need to do the address mode. Right, because it actually does something. Yeah, it doesn't like this because I need to. And it should format that properly. Good thing I tested it. Great. Okay, so then when we run, so then we go to this next page, and it says TIA get not implemented for 000E. So we can take a look at what that is. TIA general description. The registers are on page 3, so it's not very far down this. There might be another list somewhere. If that's... Uh-oh. There's a better way to look at this, so I'll open our... Is rsync. Reset the sync counter. Are we actually using that anywhere, or did I just get in a really bad state? Um, oh, no, E. We're reading the play field. That also seems very wrong. Let's take a look. Hey, Cricket. Thanks for the follow. Oh, you're raiding with a party of 4. Oh my goodness. Why didn't my raid announcement come up? How's it going? What were you working on? Did you have a good stream? I'll keep going while I wait for this. Sort of an idea territory. Games, general software, Rust, C, some other language. Um, yeah, game stuff. Cool. That's awesome. Yeah, I like I like games and I like the world around games. I still have never really made a uh like a full game. Okay, yeah, let me talk about what I was doing here. So, the folks who just showed up have an idea. Um, I am working on a Atari 2600 emulator in Rust. The reason I'm working on this emulator is because at one point a long time ago I was interested in retro gaming, and I was like, how do you build like an Atari game? Well, it turns out it's like super complicated and really interesting. Like it has a lot to do with how the television works and all that. Um, so I'm like sort of in early days of building this Atari 2600 emulator, and learning as I go. And here's what I have so far. This is for the game I built. The company I worked at had like a code test for new hires, so that was like you had to make unbeatable tic tac toe. And so I built it myself, and it's not very good, but it was like a good thing to start with because I know the code. So if I cargo run my tic tac toe game, um, so I have that is like emulating an Atari, drawing to a screen. Um, the tic tac toe thing. It handles a little bit of input. So it handles the joystick trigger, and then it gets stuck here at uh, TIA not get not implemented for 00E, which is a little bit weird to me because 00E is the playfield register, which I was looking at before. Let me see if I can. So I wasn't expecting to do a bunch of debugging today, but it has landed on my table. So this is like these are TIA write registers. Maybe there's a different read. Kaboom. Yeah, I don't even know that much about the games. I was like a little bit later to the party. I was more of a Nintendo uh like original NES person, but when it came to like messing around with the like with emulators and like building games for it, like it was just so much easier to understand. Even though the Atari 2600 is weird and complicated, like the difference in complexity of building a game between the 2600 and the original NES is like night and day. There's also a lot better. Here's the read registers. That makes more sense. Um, uh-oh. It makes more sense, but it doesn't make much sense. Um, because we end at D. Make sure I'm looking at the right thing here. I don't need to keep anything here, so. Um, so I'm gonna run with I made it a little debugger too, which you'll see pretty shortly. Let's see if I can. It's a little broken right now, but I can set breakpoints and stuff. But for right now, I just want to see where it breaks. I might be able to see a label that we're near or something like that to tell what the thing is trying to do. Um, when it breaks, all right. So this is showing all the like output for the thing and like where it is in the program, um, and stuff like that. Oh, actually, that's load playfield 1. I didn't even know that was possible. You know, this might be like a yeah. So that's not a joke. So that's first row segment. Um, this is my assembly code from back then. Aha! Look at that. I was loading something that doesn't exist to waste 3 cycles. Okay, so this is one like there's just a ton of hacks like this, right? Which is why like I don't think I should ever fail reading, but it does mean that like I don't get good feedback. So I think my tactic here is going to be eventually like you should be able to just read from anywhere, and like if it's not valid, like it doesn't care, right? Like the system doesn't care. It doesn't like say like there's no sig fault. It'll just give you garbage, or nothing or something like, and basically there's a lot of places where people just sort of do that. So we saw earlier there's an illegal opcode that I just implemented called DOP, which is double no op, which is 3 cycles long, which is used for this that doesn't affect flags. But this is 3 cycles long, and even if you load in garbage, it could affect flags based on what garbage you load in. But I clearly don't care about flags here in this part of the program. Um, so so I think my tactic here is going to be this is in the range of the TIA. There's nothing there. This is function get, and this is where I'm getting. So I could just like return 0 or something here, but that's not like that means that if we ever read something that's real, um, interesting. Uh, if we ever read something that's real, then I won't get a and it doesn't do the right thing, then I won't get a message. And I want to like as I'm implementing this, I want to get a message. I want it to like blow up and tell me that I need something. So at the expense of a little confusion, I'm just going to implement these things kind of one at a time. So so basically, if what we get here is 0x00, um, what is that? 0 then we're going to return 0. We'll return 0. And we'll just give ourselves a little comment. It's not a valid address, but is used to waste some programs. I need to return. Yeah, it didn't. Yeah, Nomad, good call. Yeah, no, I forgot. I looked up here. These are returns and not yeah. Um this is like returning the whole if statement, which is maybe not my best idea. Yeah. 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 Um I'm not going to mess with it now. Yeah, no, that's easy to miss. This is like me being like, "Oh, well, an if is a it's not a statement, it's an expression, so you can just return the whole thing, like you can with a match or whatever." But at the expense of me thinking that it was an implicit return and that I could implicit return here too. Yeah. No, you're exactly right. Uh, I'm gonna leave it for now, but there's gonna be a lot of cleanup to do here eventually. That is something close. So basically, we can talk about what happened here, but that is the tic-tac-toe board being drawn out, and the computer is always O's, and there's like a little bit of a trick about which one goes first, the computer or the player. Um, so it's there's no random number generator on the 6502. So basically, you have to like we pick the pixel or the not the pixel, the frame that they hit the button on, because that's pseudo random. So in this case, the computer started and it drew sort of half of the playing field. We know what that is. The playing field is three registers, and it's a little funky. We found out last time we did this about how it works, but it's we can see it, but it's like 4 bits define like the first little bit, and then the other is like 8 bits each. And then the whole thing can either be reflected or repeated. Um, and in this case, in the case of that first screen, let's actually just go ahead and show that. In the case of this screen, it's not reflected, so it's just like when it gets done rendering this like first one, it starts it again, and it's I wish I had lines on here. That would be a good debugging tool. Um, but then I load the playfield again, and then it just repeats. So I'm like sort of loading it each scan line on the fly. But when I get here, it is I'm asking it to be reflected. So all of this stuff should be reflected over on the right side, but it's not, and we know why. And I left it that way on purpose. So this is actually cool. So that is on the TIA, and this is wrong. It's 64 bits long and needs to be shifted, right? Um, so basically what we did, and this is the playfield stuff, and this is like I got. I wish I had a picture. Maybe I do. There's some movies there. I don't know what SS is, so I probably won't open that on stream. So, uh, hold on. I need to prove that it's not. Okay. It means screenshot. I didn't want anybody walking away from here thinking that, thinking that I had some like weird uh German World War II German iconography sitting on here, but this is what it looked like at first. There's a couple things wrong here um, with this picture. First of all, I was only drawing half the screen, but one of the other things that's really hard to see is that like some of those playfield bits, I sort of got like the wrong way around, right? And it's just like a little weird how it works. The um and we found this out last time. Like the first four bits of the playfield are in like the top bits. So if I had 1 1 1 0 0 0, it's an 8-bit register, but only the top bits matter. So the thing is if I have like 1 0, we'll ignore the rest of this. It doesn't draw. So if it's going from left to right, it doesn't draw like a playfield square on the left, or two on the left and then two on the right. It actually switches these around. So it'd be 0 0 1 1. So that's part of it. And then the second 7 bits that describe the next part of the playfield are in the same order. So if that's 1 1 1, or the second 8 bits, 1 0 0 0 0, that's the same order. But if I had the same thing in the next register, it wouldn't be 1 1 1 1 0 0 0. It would be 0 0 0 0 1 1 1 1. A lot of this stuff is built either like in one of two reasons. A lot of it's either built for um to make the hardware easier. So there's a lot of stuff that's like that's weird, but it's probably to make the hardware easier. And then some stuff is like super convenient. And like everything's a pain to do on these old things. So like some things are like it returns a value in the like eighth digit because you have like an opcode that can like do something real quick to check that. And like it's like they built it for developer ergonomics because they knew like if you had to get something out of the middle of a an 8-bit register, that you'd have to like shift it over and do a bunch of operations on it to like and like or it or something. And instead they're just like, yeah, you can have an opcode that just checks the top bit. um so that happens a lot. So I'm curious about this reflected playfield thing. um so the deal is that that is 16 plus 4, that's 20 bits, which is too much to fit in. Wait, could I put it in a U32? Oh, but I have to store it all together. So it's 40 total. So it needs to be in a U64 um for our purposes. So it's a U64 here. The thing is that like that's fine when it's we're shifting this over 20 and then reflecting it, which puts those 20 bits like that are at the beginning um like way at the end. So they're just like they're off the screen. So this should really be an easy fix. And let me think about it. If I reverse the bits, let's do it on a smaller scale. If I have, say I have 0 1, so say I had let's say 8 bits, and then I 0 1 0, and I want these ones down here, and I reverse them. I have 4 bits, and I have 1 0 or 0 1 0. Um, this is weird because I did exactly half, which makes my brain hurt. So let's not make it half. Let's make it 2 out of 8. So then if I reverse that, so then I need 2. So if I shift over 8 minus 2, does that work in general? So whatever our width is minus whatever our like desired width is. So that's shifting over 1. Sorry, let's go from here. So we shift right 1, 2. Oh, awesome. So one, two, three, 4, 5, 6. I think that works in a general case, but let's take a look. So we reverse the bits, and then we're gonna shift it over by 64 minus 20. I might leave these in here so I know how I got the calculation. And there is our board. So that I see that we're seeing 0 again, which is interesting. It means that let's just try that a couple times and make sure that I don't have something going on that like makes it always do it. No, cool. Cool. So this would be our turn. The thing that's missing here is that there is supposed to be a red uh, square pointing at where the like your cursor is. But that is, yeah. Thanks. Big win. Um, uh, but that is a sprite, and we haven't implemented sprites yet. So I do think that is our next thing to do, but I think if I just hit the trigger, yes. So then I can't do it again because I'm stuck in the middle. But that's my game starting to work. So no, I can't do anything. Let's see if I can get a. Yeah, cool. But so then I'll have to draw that sprite, and then I'll have to do a movement. Um, the movement part will be pretty easy. The drawing the sprite thing is going to be a bit of a challenge. So what I'm going to do is go ahead and take a quick break. I'm going to commit what I just did first, and then I'll take a quick break, and I'll be back, and we'll see if we can get that. What time is it? Yeah, we'll see if we can get that done tonight. That's my plan. So we're implementing an illegal opcode. Yeah. We'll do this with a different commit. And that too, and that too. Top 0x04. Since there are multiple uh, versions of that. I always make a mistake typing out my very long password there. Um, 2 is usually too many. Okay, I'm gonna add the next bit. We'll just lump it all in. Reversal. Then I'm gonna take a quick break.